So hope you have tried the two Bernoulli practice equations in the article. So now in this video I am going to discuss those two Bernoulli equations and how to solve them. So first of all, if I say something about what is this Bernoulli equation, so in the equation of the type dy by dx plus pxy equals fx y to the power n format. So if we have an equation in this format, so it's called an Bernoulli equation. For n not equal to 0 and 1, we take the substitution v equals y to the power 1 minus n to reduce this equation in the form of a linear equation. So to solve this type of equation, we take this substitution where we differentiate that equation into dv by dx equals 1 minus n times y to the power minus n dy by dx. So the equation is this. So we have to divide this whole equation by y to the power n, and then we get 1 over y to the power n dy by dx plus y to the power 1 minus n px equals fx. So here we can write this in 1 over 1 minus n dv by dx plus, so here is vpx equals fx. So likewise we can reduce this into the linear form, and then we can take the solution as linear equations. So by looking at this question, we have dy by dx plus xy equals xy squared. So here we can take v equals y to the power 1 minus n is 2 here, so y to the power minus 1 as v. So then dv by dx equals minus 1 y to the power minus 2 dy by dx, and then we can write y to the power minus 2 dy by dx plus y to the power minus 1 x equals x. When we divide this equation by y squared, we get this equation, and then now we can substitute here minus dv by dx plus vx equals x, and then we get dv by dx minus vx equals minus x. So here this is in the linear form, and we can check for integral factor here. So integral factor here is e to the power minus x dx. So here we get e to the power minus x squared over 2, and so multiplying the whole equation by the integral factor x squared over 2 dv by dx minus e to the power x squared by 2 vx equals minus e to the power minus x squared over 2 x. And we can now write this whole thing as the integration of v e to the power minus x squared over 2, and integrate this ex squared over 2, and then we have here we have v e to the power minus x squared over 2 equals a minus x squared over 2 plus c, where c is an arbitrary constant. So so by back substituting for v equals 1 over y, so v equals 1 over y here, and then by dividing by this, we get 1 plus c e to the power x squared over 2. So here we have got an equation 1 over y equals 1 plus c e to the power x squared by 2. So that is how we solve the first Bernoulli equation. So the thing is, we have to take the substitution v equals y to the power 1 minus n, and taking it to the linear form, and determining the integral factor, we can solve the equation. So moving on to the second one, we have dy by dx plus xy equals y squared e to the power x squared by 2 sine x. So here also we have to take the integral. Before taking the integral factor, we have to determine v. V is 1 minus 2. So here y to the power minus 1 is v, and dv by dx equals minus 1 y to the power minus 2 dy by dx, and y to the power minus 2 dy by dx plus x y to the power minus 1 equals ex squared over 2 sine x. So we get this equation by dividing this whole equation by y squared. So by substituting here, minus dv by dx plus xv equals e to the power x squared over 2 sine x, and so multiplying by minus, we get this equation. So determine the integrating factor. Integrating factor is e to the power minus px. So here px is minus x dx. So here we get e to the power minus x squared over 2. So multiplying the whole equation by the integral factor dv by dx, we get e to the power minus x squared over 2 xv equals e to the power x squared over 2 e to the power minus x squared over 2 sine x. So then we can determine that this is the differentiation of e to the power minus x squared over 2v, and this here these two get cancelled and we get minus sine x. So taking the different integration of the both sides, we get e to the power minus x squared over 2v equals cos x plus c, where c is an arbitrary constant. So here substituting a subject in v, we get 1 over e to the power minus x squared over 2 cos x plus c. So back substituting for v equals y to the power minus 1. So 1 over y is e to the power x squared over 2 cos x plus c. And again we can substitute subject y here, taking the reciprocal, e to the power x squared over 2 cos x plus c. So here we got the answer for y is 1 over e to the power x squared over 2 cos x plus c. So that is how we solve the Bernoulli equation, by determining the value for v, taking a substitution for v as y to the power 1 minus n is here 2, and then we solve it for a linear equation, and then we determine the integrating factor, and then we multiply the whole equation by integrating factor, and we determine the left hand side as a differentiation of a function, and then we got the answer, final answer, and in explicit form as y equals 1 over e to the power x squared over 2 cos x plus x. So that is how we solve the Bernoulli equation. So if I made a recap, so the type of the Bernoulli equation is dy by dx plus pxy equals fx to the fx and y to the power n format. So this is the format of the Bernoulli equation. We have y to the power n here. So hope you have gotten clear, nice idea about this Bernoulli equation and how to solve them. So stay tuned for more on the ordinary differential equations in this article series. Thank you.